Good afternoon, one and all present here. Dear participants, I wish to wish all the teachers gathered here a happy Teachers' Day. Now, I request our Dean Research and convener of this international workshop, Dr. J. Jayanti, to welcome the gathering. Ma'am, please.
A very happy Teachers' Day to all. Good evening to one and all present here. On behalf of the Guru Nanak Center for Research, Guru Nanak College, I welcome all the participants to the Day 3 of the International Workshop on Recent Trends in Technological Advancement in Aquaculture and Fisheries. Today, we have amongst us Professor Bright Singh, Emeritus Scientist, National Center for Aquatic Animal Health, Cochin University of Science and Technology, Kerala, who will talk on entrepreneurial opportunities through BAKYARD's recirculatory aquaculture system and fish farming. I request Dr. Shivakumar, Assistant Professor, PG and Research Department of Advanced Zoology and Biotechnology, Guru Nanak College, to introduce our resource person of today.
Thank you, ma'am. So again, very happy Teachers' Day, all the professors. So a very good afternoon to all present here. I deem it privilege to introduce today's chief guest, Dr. I.S. Bright Singh, for third day of 8-day workshop on recent trends in technological advancement in aquaculture and fisheries, organized by the Guru Nanak Center for Research, Guru Nanak College, VELACHERY, Chennai. Dr. Bright Singh secured his MSc Marine Biology from Annamalai University in the year 1979. He pursued his doctorate from School of Marine Sciences, Cochin University of Science and Technology, Kochi, in the year 1986. He started his career as a junior assistant professor at College of Fisheries, Kerala Agriculture University from 1983 to 89. He promoted as an assistant professor in the same institute from 1989 to 1991. Later on, he moved to Kochi University of Science and Technology and served as a senior lecturer from 1991 to 1996. So during 1996 to 2004, he worked as a reader in School of Environmental Studies at Cochin University. Simultaneously, he acted as a coordinator for National Center for Aquatic Animal Health. In the year 2004, then he promoted as a professor in the same university. Later, he promoted as a director at Cochin University of Science and Technology from 2006 to 2009. Finally, he promoted as a dean, Faculty of Environmental Studies from 2007 to 2010. Currently, he is an emeritus scientist at KSCSTE, Kerala State Committee on Science, Technology and Environment. He is recipient of many awards. He received a fellowship award in National Academy of Agricultural Sciences, ICAR, New Delhi. He is also a recipient of UGC BSR one-time grant of Rs 7 lakhs. He is a visiting professor. He was in microbiology from 2001 to 2008 at Northumbria University, UK. So UGC visiting associateship for the year 1993 to 1995 for development of new fish cell lines at Trivandrum. He also received a Young Scientist Award in Fisheries in the year 1989 by KSCSTE. He received a Dr. S. Jones Memorial Award in the year 2014 for his outstanding contribution in the marine biology by Marine Biological Association of India. He received several grants from various funding agencies like UGC, DBT, DST, etc. So in the year 2009, he received rupees 57.3 lakhs from DBT for white spot syndrome in shrimp. During 2010, he received a grant of rupees 40.2 lakhs from DBT. So the total grant of ongoing project is 2 crores 88.79 lakhs. So far, he completed 23 projects. He participated in various expert committee constituted by Government of Kerala. As an organizing secretary, he conducted several international workshops, conferences, and symposia. As a coordinator, he also established a new center for fish disease diagnosis and management at Cochin University of Science and Technology in the year 2006. He guided 30 PhD candidates under his guidance. Still 12 more candidates are pursuing their PhD degree under his guidance. He is also a reviewer in several national and international reputed journals. To name a few, Aquaculture International Springer, Aquaculture Elsevier, Indian Journal of Virology Springer, etc. He has 6 patents to name a few: a coir-rating bioreactor, mass production of an aquaculture probiotic, Pseudomonas, etc. He published many books. He published 80 papers in various peer-reviewed national and international journals. He also written 20 chapters in books. He presented 50 papers in many national and international conferences. He also submitted 147 16S ribosomal RNA genes to the NCBI Gene Bank. Really, we are proud that Dr. I.S. Bright Singh, such an eminent personality, for having accepted our invitation in spite of his busy schedule and being here today with us. Over to you, sir. Thank you, sir.
So now we invite you to present your presentation, sir.
Thank you very much. Dear viewers of this program, at the outset, let me express my hearty thanks to Guru Nanak Center for Research, and especially to Dr. J. Jayanti, convener and Dean Research and convener of this program, and Dr. Sivakumar, who introduced me, and Dr. M.G. Raghunathan, Principal, and Sardar Manchit Singh Naya, General Secretary and Correspondent. And once again, and express my thanks for giving me an opportunity to speak about a technology which we have been working for a long time. The photograph which you see here on the screen is the first backyard RAS established in Kerala. It situates in the northern part of the state in Kannur district. And henceforth, till awesome as on today, we could establish 85 such units in the state. So I would like to explain you this story. When we look into recirculating aquaculture system, in short form RAS, the concept and idea is water is fully or partially recirculated. During this process, dissolved and particulate organic matter is removed, ammonia is converted to nitrate, sufficient oxygen is provided. If any pathogen gets into the system, disinfected, pH is regulated. Ultimately, RAS becomes a very expensive business and most popularly known unaffordable by common man. So we wanted to make it affordable to the people in India. What is a way out? One way out is indigenization, and second thing is simplification of the technology. And accordingly, we have been working for a long period of time through various externally funded research projects, exactly not on RAS, but different components of RAS we have been working on. And accordingly, Government of India sanctioned projects. The first projects which came on 1995, in which we developed a bioreactor technology. And second project from DST, where in which we worked on the nitrifying bioreactors and the biofilm, nitrifying biofilm, its structure, population dynamics, kinetic modeling, and all could be done from the period, during the period 2006 to 2009. Then again came another DBT project in 2007 and extended 2010. And again, DBT supported for another project to test these reactors at field level during the period 2013 to 2016. So you can understand that for a long period of time, DBT had been with us in supporting this particular technological innovation to make sure that people of the country gets a technology at a very less expensive, very less cost, which otherwise would have been unaffordable. And what I present now today is the summing up of 5 PhDs. That means all along this period, 5 PhD students have been working in these projects, and these are the 5 research scholars, as you see here on the screen, and they are in different areas now. What is the requirement of cost effectiveness and user friendliness? Less capital investment must be affordable, less recurring cost, least breakdown, and easy and continuous harvesting, and easy to operate, and moreover, everyday fish production. That's a very important point. Every day we must be able to get fish from that continuously throughout the year. So with that in mind, we designed a high-density fish culture under RAS mode integrated with the vegetable cultivation as backyard RAS, with an objective of ensuring food security and livelihood. On seeing the potential of this technology, National Fisheries Development Board entrusted NCAH to implement the technology need-based all over the country under the Blue Revolution scheme with subsidy. That was the situation in 1990 to 2000. Now in this year, 2000 to 2001, Government of India has recognized this technology as 100 cubic meter RAS under Prime Minister's Matsya Sampada Yojana 2020, and this is also given subsidy. So attractions of this project are cost less than 10% of the conventional RAS because of indigenization of the whole technology. Nutritional security in different parts of the country can be assured because they can be established anywhere you want. A water body nearby is not required. With well water, groundwater, stream water we can run. Very little water exchange is required, almost nil. Then this forms livelihood to a family. A family having 1 cent, 2 cents of land, which can be separated for this, according to our estimates, if a person have 2 such units, not less than 50,000 rupees per month can be made for the family. And moreover, this technology is so user-friendly that homemakers can manage. By that way, we assure women empowerment. What are the advantages of high-density aquaculture under RAS mode? One is requirement of small area, large production potential, biosecurity, culture completely under control with less uncertainties. It is within our control. Sequential stocking. Every month we can stock. Every day we can harvest. Continuous year-round production. As I said, everyday harvest. At the same time, when you look into high-density fish culture, where we stock not less than 50 fingerlings per cubic meter. Now, normally, if you go to pond-based production, in 1 square meter with 1 meter depth, having 1 cubic meter, we will stock only 5 animals. In that place, in the same quantity, here in high density, we stock 50 animals. So when such high density fish culture is implemented, there are so many challenges will come up, and they are need of frequent removal of fecal matter and uneaten food, ready conversion of ammonia to nitrate, requirement of ready removal of nitrate, controlling of excessive bloom of algae, steady supply of dissolved oxygen and its maintenance to above 5 ppm, and stable water chemistry. These are the 6 challenges. Now let us look into these challenges with some detail, and we will see how these challenges were addressed. When we look into an RAS, fecal matter which is produced by the fishes should be hard and heavy to sink to the bottom. So the feed must be of that category, and it must be given with the additives so that the fecal matter becomes hard and being eliminated. Floating a fecal thread is a sign of indigestion and bulking. Only 20% of the feed consumed should be leaving the body as fecal matter. This fecal matter should not get disintegrated. Bottom of the pond should have sufficient slope to get the fecal matter accumulated at the center. An efficient sludge removal system must be there. These are the needs of frequent removal of fecal matter and uneaten feed. So this was the first challenge which we addressed. Second one is ready conversion of ammonia to nitrate. For that, an active nitrification system has to be established. Nitrifying bacteria in the water column is usually very less, and biological filters or bioreactors are required for its rapid nitrification. Different designs are available for nitrification, such as submerged, packed bed, fluidized bed, rotating biological contactors. All are energy-intensive processes and get clogged easily. Trickling filter has been made the choice as it works on gravitational force and does not get clogged easily. That is a merit of the system. We use trickling filters where no power is required other than just pumping the water in the overhead tank and allowing to fall down by gravitational force. But invariably should get activated using nitrifying bacterial consortia. So in the early period, 1995-6 period, our attempt was to develop the nitrifying bacterial consortia. The fermenter what you see here is the one in which we originally developed this consortia. This fermenter is still functional. Then we transferred this consortia of developing into bigger vessels which were made indigenously as fermenters which we fabricated. Yeah. Then finally this has been transferred 150 liter, 1500 liter capacity fermenter where we produce the nitrifying bacterial consortia for the production or the setting up of the trickling filters active. And this is the overall dimension of a trickling filters here. You can see here, and water comes from the overhead tank and comes down and trickles down to the filter and flows down. And when it is being done, you can see here the holes given. Air enters into the cartridges, and when water comes down, air moves in the opposite direction, so that the entire medium is aerated, and in the medium, which are plastic, there are nitrifiers abundantly immobilized. They do the conversion. Third one is the ready removal of nitrate. When nitrification happens, which is done by chemolithotrophic bacteria for getting energy, ammonia is converted at the first stage to nitrite, an oxidation process, then nitrite to nitrate. The two different groups are working. And when nitrate gets accumulated, it could become a difficult situation for the removal of nitrate, even though they are not toxic at a low level. And rapid and continuous nitrification leads to accumulation of nitrate, and high concentration nitrate leads to toxicity. Both goes for 100 ppm. But here, there are two ways by which we can remove these nitrates. One is denitrification. Another one is utilization of nitrate as nitrogen source by microalgae. Fortunately, the consortium what we developed has the denitrification potential. And this is carried out by the heterobacteria which are resident in the consortium. So the very moment the nitrifiers, the chemolithotropes produce nitrite and nitrate, and these heterotrophs convert this nitrate to nitrogen and expel it from the system. This takes place in oxygen deficient situations, but here in our consortium, apart from that, they function aerobically. And this has been a research which we have been carrying out for a long time and finally proved that these consortia, these bacteria can work or do denitrification even at aerated condition. And this happens when water passes through the trickling filter. So the water which is coming out of this trickling filters must be free from ammonia and with a less quantity of nitrate. And if nitrate are remaining, there will be microalgae in the system. They will consume as nitrogen source. And if the algae are not developed, we have got the technology to introduce microalgal culture even. But when such a process is going on, you must be wondering, won't there be any excessive blooming of algae? When microalgae grow in such system with available nutrients, there is possibility of overblooming, turning the water dark green, and examine. We had to, in that particular situation, we examine the water chemistry and regulate feeding, and gradually the bloom will be subsided. And for partial removal of the excess bloom, a filter is also provided in the system with which we can remove the excess algae. And microalgal blooms supply sufficient oxygen. And during daytime, when there is sufficient sunlight, the air injectors can be switched off. So the air injectors are provided for giving oxygen. Those can be switched off even when the microalgae are good in number during daytime. Fifth target or the challenge is to provide steady supply of dissolved oxygen and its maintenance to above 5 ppm. In RAS, 5 ppm oxygen, dissolved oxygen, is invariably required. So this oxygen is required not only for fishes, for all biological components, which includes fish, bacteria, fungi, algae, protozoans, and there are so many chemical reactions as well, and for all these oxygen is required. And as I mentioned, microalgae provide some quantity of oxygen during daytime, but nighttime we will have to provide oxygen through aeration. There are so many devices for providing oxygen. Air compressors and air blowers are the two important devices for aeration such system. So in that, we take air from that, we have to bubble air through water. But bubbling air is very inefficient way of aeration, as the efficiency is only 25%. The 25% of energy which we put on the machines alone is translated into oxygen. In its place, we installed air injectors, or we designed air injectors and used which saturate water with air and inject into the water column. So during this process, water gets aerated adequately. At the same time, because of the specific design of the system, water gets swirled gently, facilitating the detritus to get accumulated at the center. So these are the two things which we accomplish by using air injectors in the place of just aerators. So having this at the background, we'll just look into the overall design of high density fish culture. This is the overall design. You can see here the culture tank, and then from here you can see 3 pumps, and they pump water to an overhead tank, and from here it comes down to a trickling filter and goes back into the system. At the center you can see a pit, and then a pump, which is a slurry pump that can take from the bottom of the tank the slurry which got accumulated and take outside. And this water and slurry can be used for vegetable cultivation. And here you can see the blue colored structures. They are the air injectors. They are kept at the periphery, and 4 of them for one system in one direction. And when they work either clockwise or anti-clockwise, there will be a swirling motion. Because of the special configuration of the system, this swirling motion get or accumulate all the detritus to the central portion and gets accumulated, and make it possible for the slurry pump to suck it out when it is operated just for 2 or 3 minutes. If you take a cross section of the fish tank or the culture tank, we'll see this as the dimension. Here 2 meter depth, and here the center 3.3 meter depth. From here up to this portion 3 meter depth, and there is a slope of 18 degrees from the side, and it reaches a pit. The pit has got a dimension of 30 centimeter into 30 centimeter, either square or circular. And this The tank has got a dimension of 6.7 into 6.7 and depth is 2 meter and slope is 18. Ultimately, we will get volume of water up to here 90 cubic meter. If we take the volume over into the conical portion, we get 100 cubic meter. So that's why it is nomenclatured as 100 cubic meter RS. Now coming to the trickling nitrifying bioreactor, which I have been telling you, and which has been designed, and this is the outer shell of the system. It is given with all perforations for the easy air to pass when it works. And this is overall interior interior structure. You can see here the center, dark is a cartridge, which is made of plastic, and they are perforated. And here the nitrogen bacteria immobilized. They form a very thick biofilm. When water falls down, as it trickles down and goes back into the system. And this is the way in which they are organized at field level. Now you can see a tank over here, a overhead tank here. The water comes down, and this can be very much regulated. The flow of water can be regulated and flows down and enters into the culture facility. And these are the pumps which are kept here for pumping water. And all these can be regulated. And this pumping is regulated in correspondence with the flow rate by using a float and a sensor. And this is a real-life picture of a pond under construction. And this structure is made of bricks, and here 2 meter depth, and then here comes the slope, a central pit. What you see here as blue structures are the air injectors, and we used the Venturi aeration system, the Venturi principle. And at the center, you can see the slurry suction device and 2 motors here, 0.5 horsepower. One motor is used for taking water to the overhead tank. Another 1.5 horsepower slurry pump is used for taking away the slurry. And these air injectors are operated with 0.5 horsepower pumps. And there is a polythene lining, so a concreting is not necessary. So this I have already shown. In that situation, this is the way in which it works. Water is pumped up and goes down, which can be regulated using valves. Now, as I said, the dimension 6.7, 6.72, and effective depth 2 meter, maximum depth 3.3 meter, area 44.89, 45 square meter, volume, effective volume 90 cubic meter, bottom conical with a 18-degree slope, and with a central slurry accumulation pit. This is the overall dimension. The technological points which have been addressed by having this simple design are: the pond design has been made for optimum energy utilization, because when we aerate, we do not aerate only, we aerate for generating circulation of water, a swirling motion, continuous motion, that results in accumulation of sludge at the center. And by way, we provide sufficient oxygenation also. Nitrification and denitrification are clubbed together. For that, we do not demand, there's no energy demand for that. Instead, water is pumped up to the overhead tank, it comes down, and through gravitational flow, it goes to the pond. And hydrogen sulfide mitigation, which is a very important point in RAS, because wherever there is a noxious condition getting generated, H2S will form. H2S is a silent killer, more than ammonia. And that is being mitigated by fully aerating the system. There won't be any pockets where there is a noxious condition. And solid waste removal with less energy, because when we operate the slurry pump, it will last for only a few minutes, 1 or 2 minutes, within which all slurry got accumulated at the center by the swirling motion will have got pumped out. very less energy is required. Then comes the consistent water chemistry management by all these means, and for that we have got other devices as well. Then gut flora and immune stimulation modulation, there are devices and means and tools, and there is preventive healthcare always been implemented. These are the technological points or innovations which have been brought into this system. And this is another real-life situation when a pond is under constructed using bricks. So you can see a simple construction on a ground which is fairly hard enough, where we can dig and construct and make a slope and put a polythene lining over. Now let us come to the aeration facility for optimum oxygenation. As I mentioned, we use Venturi system because steady supply of oxygen is very, very important in the system. We cannot wait for even 10 minutes without oxygen, because such an oxygen demand will be there because of very heavy density of fishes. And as I said, it is for entire biological community in the tank. There are several oxygen providing devices, I said. One is the compressor, another one is air blowers, but here we use Venturian system, as you see here. This is a Venturi aeration system, and water is taken from here, this point, and using a pump. This is 0.5 horsepower pump. It is pumped to the system. Because of the speciality of this design, air is sucked from the top and mixed here. It is pumped out. The water coming out is saturated with oxygen. And this is powered with 0.5 horsepower centrifugal pump. Placed 1.5 meter below water level. 4 systems in a pond, positioned at equal distance to create circular motion of water and accumulate solid waste at the center. And here you can see a drawing how these aeration facilities are implemented. Here from the bottom, at this point, around 1.5 meter from the top, here. And this is the way in which they are being installed, and they are the pumps are kept on the surface, on the wall of the pond. What you see here is another device known as flushing system. If you want to flush the sludge which is accumulated here, we can operate a pump which is already installed that will take water and flush through these pipes which are perforated, that wash down the entire sludge to the central portion where the slurry suction device is placed. Even though we operate in such a way, there could be power failure. When the power failure comes, the normal thinking is we should have a generator. Here in this system, 3.5 horsepower power is required, and we have to spend a lot for having a generator. So instead, the device what we made was to provide an emergency aeration system which can be operated by 390 watts air pumps, and which can be separated with the air inverter and the battery backup. And this inverter will support just aeration alone for 4 hours. And even it exceeds, if it exceeds 4 hours, the power's failure, only we have to think about the generator. For that also, we have identified a very simple generator which can be installed with 35,000 rupees. So this is known as the emergency aeration system, which will be operated during emergency period or at night time. This can be operated or put online so that if there is power failure, this will continuously start working and keep the fishes alive. And you have to understand that always the circulation of water through the filter is not required. Even if 5 to 6 hours of stopping of circulation is not going to matter much. Only thing is, aeration must not be able to be disconnected. Now let us look into trickling nitrifying bioreactor, which is the heart of the whole technology. And this you have seen this figure already, how it has been installed. So we have worked out the requirement of trickling filters. 3 filters are required for one system. So you can see 9 and 3 systems are under operation for a farmer. And lots of studies have been made on the nitrifying bacterial consortium here. And this has been the of a topic of 2 PhD theses. And we worked out the entire array of organisms presented, a multitude of organisms, which are stable enough to remain at 4 degrees centigrade in the refrigerator, and it can be cultivated easily in a fermenter with a mineral-based medium, can be harvested, can be used for immobilization on the cartridge. And we, based on fluorescent in situ hybridization, also we made studies and confirmed that they consist of Nitrosococcus mobilis, Nitrosomonas, Nitrospira, Nitrobacter. All these are present in this consortium. These are the data which we could generate over the years. And another interesting feature is that when we install the system and work for a couple of months, we could see that efficiency of the system, the nitrifying bioreactor, was increasing day by day. As you see here, 96th day, it has gone to very high level. So there will not be any cessation of activity, even if in case there happens a reduction, very easily we can activate within 2 to 3 days, or the same day we can replace it with another set of activated cartridges. And this is the dynamic role of nitrifying bacteria consortium, representing a vast variety of organisms, which takes care of the entire biological process, which is to happen in water to make it adequately good enough for the fish to survive. Now this is being cultivated in a large 100,000 liter fermenter. If you want to make sure that this system can be used for continuous harvest and continuous marketing, then there must be sequential stocking to happen in a system. In the 90 cubic meter, we can stock around 6,000 animals. And that if you harvest on a day, so much, around 6,000 kilo, 6 ton fish being generated. But that what would happen, that it would be very difficult for the farmer to sell it. So what we thought of, to fragment it, to divide the whole system into 3 compartments, and then only we can assure nutrition security in a place. The whole concept is that if a system is implemented or installed in a place, in a household, all those people nearby, around 2 to 5 kilometer radius, must be able to come and buy this fish every day. So what was done? It was divided by having 3 floating cages, and each floating cage will have approximately 30 cubic meter. Now we have to think about the solid waste removal. As I mentioned earlier, we have made it a very simple system and very highly energy efficient. We have never kept any physical filters over in the system. That's a specialty. No filters, no sponge filters, no drum filters. Drum filters is too expensive to install as well as expensive to operate. It needs 3 horsepower pump. Rapid and slow sand filters will also clog. Hence, we decided to use gravitational force to pull down the solid from the water to the bottom of the pond and use the air injector to get it accumulated at the center and to have a solid waste slurry suction device designed and fabricated by us. As I said, unidirectional flow of water that creates the motion and then settling. Can see this device kept here, which is connected to a pipe, through a pipe to a pump. This is the device. And this has got 80 kilogram weight because it has been made so heavy to remain in a constant, in a same place over months and years without any movement. And a pipe from here goes to the bottom of the pit and almost touches. And through that, the slurry is pumped out. This is how it is being installed in a system. This is a pit. The pipe goes to the mid center, to the bottom, and all the slurry comes and gets settled inside this pit. Let us see a video how it works. Now the water is clear and the pump can be switched off. This is all the technology which has been developed and installed. Now let us look into the species of fishes which can be cultured in this backyard arrays. A variety of fishes. We started with the gift genetically improved farm tilapia. Then we moved on to bird spot and Pangasius. And yet to try snapper, Jayanti rohu, and pompano, and scampi and sea bass. All are good enough for cultivating in this system. And marine species can be cultivated if we install this facility near to sea or brackish water. So based on the chemistry of water, we can change the species. That's the beauty of the system. And the nitrifiers, which are required for different quality of water, having different salinity, we have with us, and we can change the consortium accordingly. And this indicates the high flexibility of the technology. Another important component which has been integrated into the technology is a preventive health care. To prevent diseases, first thing is to maintain optimum water chemistry, in which dissolved oxygen must be above 5 ppm at the bottom of the pond. Periodic sludge and slurry removal, optimum feeding to avoid wastage, regular probiotic application, which we have got our own. That's what we have been working for years together to develop our own probiotics, named as Entrepreneurship, a marine yeast, then PS1 is Pseudomonas, then a detrodigest, which is made of bacillus, composed of bacillus to remove or to digest organic matter. All these are integrated into the system. Later, we found out that the feed what we use is deficient of calcium, micronutrients, and vitamins. And we have made arrangements or facilities for supplementing the feed with vitamins and with the calcium to compensate the deficiencies in the feed, which is commercially available. And we now use rock salt as a source of micronutrients even. These are the products which we have got, which are integrated into the technology. If we just mention them, we'll see that detrodigest is an organism which can rapidly degrade organic matter, especially dissolved organic matter. Now, in this place, what normally people are using is a protein skimmer. That is again an expensive business. Avoiding that, we now use detrodigest to digest it and then eliminate by further nitrification, denitrification in the biological filter or bioreactor. Entrepreneurship is a combination of two organisms, a bacillus and a micrococcus, which is a gut probiotic which regulate gut microbial flora. Marine yeast is a Candida species which provide beta-1,3-glucan as immunostimulant. It is a store of essential micronutrients, vitamins, and minerals. Pseudomonas PS1. It is an antagonistic bacterium which can control a variety of pathogens in the gut. Gut is the portal of entry of all these pathogens. So all these are integrated into the technology and given to the farmers. Another important point is a consistent water chemistry management. As you know, the fishes or all aquatic animals other than mammals are poikilotherms, and depending on the change, what happens in the water, the body physiology also changes. So they always like to have a consistent water chemistry, including temperature. So this is a major constraint in the and difficulty experienced in RAS. So for that, we have designed an on-site mini water chemistry lab, which is attached to the facility. And by using this laboratory, we can have the farmers are educated to utilize the facility. There is continuous monitoring and correction by way application of dolomite or other calcium or magnesium salts, and effective nitrification and denitrification by way of using nitrifying bioreactors, efficient oxygenation, and feed management, effective removal of detritus, management of algal bloom. With all this, we maintain a consistent water chemistry. And for that, the mini on-site water chemistry lab, which costs only just 20,000 rupees, is highly useful. And in that, we can measure pH, alkalinity, calcium, magnesium, total hardness, ammonia, nitrate, dissolved oxygen, and hydrogen sulfide, and determine the range at which we have to maintain for best results. And this has also been communicated to the farmers. And when we analyze the cost involved in analyzing all this, it comes to just 42 rupees for a farmer. This is how it looks like. You can see a colorimeter here, test tube stand, the distilled water, and all reagents, and we use syringe in the place of pipettes, and a thermometer, and can be very comfortably managed by a farmer. And a part of the technology dissemination, we give training to each and every farmer. They are brought to our laboratory and then trained once, and our technical personnel go to their homes and set up the facility and train them again there and provide them all the reagents and monitor online from our laboratory. These are certain images of the training which we have imparted to the farmers or beneficiaries. Entire unit is manufactured at NCH. There is an aquaculture engineering production unit at this institution, and it has got the capability to manufacture 25 RAS units per month, and we can have more shift. We can go up to 75 in a month. And we have got facility to bulk transport them to any part of the country through railways, and we have done several such experiments, and they are all very much effective and cost effective also, and very much comfortable for carrying out. And just a few highlights about the productivity of the system. Now, a single pond having 3 cages, of which each can hold 2,000 fishes, total 6,000 fishes, and preferable harvesting size 350 gram, and total production 2,100 kg from single pond, and yearly 3 times harvesting comes to 6,300 kilogram per year. 3 times we can harvest and regulate the whole culture period meticulously by the management from the date of stocking to the harvest, just 90 to 120 days, then goes to the next stocking. So we have been studying the performance system, and here one such data. And during a period of 120 days, 1,980 kilogram fish, and feed consumed 1,912 kg, and it's a feed conversion ratio of 0.99. And what is the overall impact of this technology? There are four. One is women empowerment. As I said, women in the home can manage. Nutrition security, because we are producing fish in throughout the country. Wherever we want to produce, we can produce fish. Along with that, there is livelihood expansion. The home can run the whole expenditure with this system. Employment generation through opening up enormous entrepreneurial opportunities when this is being extended nationwide. And when we look into women empowerment or livelihood expansion, we'll see that RAS unit has been designed in such a way that women can own and operate single-handedly and generate extra income for the family, access a nutrition security by providing fresh fish everywhere, employment generation through entrepreneurship, installation of RAS units for speedy dissemination, regular supply of fish, seed and feed, marketing fresh fish with or without value addition, and hand holding, very important, because we have experienced that every farmer need continuous support in terms of information and solving their problem if it already comes. For the hand holding is very, very important. And when we look into entrepreneurship, the opportunities are by having organic live fish production and its sale as a primary goal, and increasing marketability by value addition, dressed fish, ready to cook, marinated or pan-ready fishes, fillets, fish pickles, dried and smoked products, all can be envisaged from this production facility. And value-added byproducts can be thought of, scales for gelatin production, fish skin a possible therapeutic for burns, and fermented fish viscera obtained while dressing fish a possible source of fish meal in feed manufacturing. All these can be put together. There is a tremendous scope for entrepreneurship. Another untouched area is a slurry which is removed from the bottom of the pond along with a bit of water, and this is a complete manure because it consists of all macro and micronutrients required for plants. And several farmers tried and they said tremendous results in the production. When we look into the cost effectiveness, just we'll see that, as I said, 0.9 is the FCR. And here 3 times harvesting, yearly 3 times. And this particular facility system consists of enormous biodiversity in terms of small animals, and which form food for these fishes. This is a healthy sign. And the cost of production we worked out, it comes to around 103 to 110 rupees per kg. And this is a typical case study. And for one system of one pond of a farmer, we investigated. You can see here 11,31,657 a year. And when we look into the returns, what we could see was within 1 year, with this expenditure, which he invested 8 lakhs for the pond. Now, according to our concept, only 1.8 lakhs required for a pond. In spite of such a heavy expenditure incurred by a farmer in a place where there was very difficult situation for constructing a pond, we could see that within 1.5 years, he was able to recover the entire expenditure, even without subsidy. Women empowerment can be seen in this photograph, and most of the cases are managed by women. This is a new system which we constructed in Trivandrum along with the Department of Aquatic Biology and Fisheries of Kerala University, which is said to be commissioned. A value-added product. How the stocking, about the stocking, as it is being stocked in a normal system. Some videos. The harvest festival, the inauguration of harvest.
Organic fish farm ആണ്. കുറഞ്ഞ സ്ഥലത്ത് കൂടുതൽ മീൻ വളർത്തുന്ന ഹൈ ഡെൻസിറ്റി റീസർക്കുലേഷൻ സിസ്റ്റമാണ് ഉപയോഗിക്കുന്നത്. ഈ രീതിയിൽ വെള്ളം ശുദ്ധീകരിച്ച് വീണ്ടും ഉപയോഗിക്കുന്നു. ഓക്സിജനും ജൈവ ആഹാരവും പ്രത്യേകമായി നൽകും. ചടങ്ങിൽ പയ്യന്നൂർ ബ്ലോക്ക് പഞ്ചായത്ത് പ്രസിഡന്റ്
ശേഷം തങ്ങളുടെ വീട്ടുമുറ്റത്തെ 2 സെന്റ് സ്ഥലത്തൊരുക്കിയ നൂതന മത്സ്യകൃഷിയാണ് മറുനാട്ടിൽ നിന്നെത്തുന്ന വിഷമീനുകൾക്ക് ബദലായിരിക്കുന്നത്. ശുദ്ധമായ മത്സ്യം ഉൽപ്പാദിപ്പിക്കുക എന്ന ലക്ഷ്യത്തോടെ കൊച്ചി ശാസ്ത്ര സാങ്കേതിക സർവകലാശാലയുടെ ഉപവിഭാഗമായ നാഷണൽ അക്വാറ്റിക് ആനിമൽ ഹെൽത്ത് വികസിപ്പിച്ചെടുത്ത ഹൈ ഡെൻസിറ്റി റീസർക്കുലേഷൻ സിസ്റ്റം വഴിയാണ് മത്സ്യകൃഷി നടപ്പിലാക്കിയത്. കേന്ദ്ര ഗവൺമെന്റ് സ്ഥാപനമായ വിജയവാഡയിലെ രാജീവ് ഗാന്ധി റിസർച്ച് സെന്ററിൽ നിന്നും സ്വാദേറിയ ഗിഫ്റ്റ് തിലാപ്പിയ ഇനം മത്സ്യക്കുഞ്ഞുങ്ങളെ വാങ്ങി ഫിഷറീസ് വകുപ്പിന്റെ ലൈസൻസോടെ 100% ജൈവ ആഹാരം മാത്രം നൽകിയാണ് മത്സ്യത്തെ വളർത്തിയെടുത്തത്. വീട്ടുമുറ്റത്തെ 2 സെന്റ് വരുന്ന സ്ഥലത്തെ ആധുനീകരിക്കും.
And one farmer could do Intl suratensis, and there's a very good harvest within 6 months of growth. And for this Intl, if they are grown in fresh water, there is a different recipe to be given along with the diet.
Good morning, all of you. I'm Satish Kumar from Trishur.
And this is another farmer from Trishur. And he is explaining what he has been doing. And there is a compared to a higher stock intensity he has given.
നെക്സ്റ്റ് ടാങ്കിൽ ഒരു 6000 കുട്ടികളാണ് ഇട്ടുന്നത്. ഇതൊരു 1 month ഡിഫറൻസിലാണ്, പക്ഷെ കുട്ടികളൊക്കെ 200 മുകളിലായിട്ടുണ്ട്. 200 to 300 ആയിട്ടുണ്ട് ഗ്രാംസ് ആയിട്ടുണ്ട്. ഒരു 6000 കുട്ടികളാണ്.
He's telling that they have grown to 250 to 300 grams.
ജസ്റ്റ് വെള്ളത്തിന്റെ ഒരു ക്വാളിറ്റി ഒന്ന് നിലനിർത്താനായിട്ട്. ഇതിപ്പോ പെറ്റിന്റെ വെള്ളം ചെറുതായിട്ടൊന്നും മോശമായിട്ടുണ്ട്. അതിന്റെ ഫിൽറ്റർ ഒന്നും വർക്ക് ചെയ്യുന്നില്ല കേട്ടോ.
He has made aquaponics bed also along with that, and that he grows vegetable. That's what he is doing.
വെള്ളം നല്ല വെള്ളമാണ്, നല്ല ക്ലീൻ വെള്ളമാണ്. 3 ബെഡ് സെറ്റ് ചെയ്തിട്ടുണ്ട്.
There is aquaponics bed connected with this
വാട്ടർ ഫിൽട്രേഷൻ. ഇതിലാണ് ഏറ്റവും കൂടുതൽ നല്ല വെള്ളമാണ്. മറ്റുള്ള ടാങ്കുകളെ അപേക്ഷിച്ച് നല്ല വെള്ളമാണ് ഇതിന്റെ. കാണാനായിട്ട് ബെറ്ററാണ്.
And what you see here is a one pond of 6.7 to 6.7 into 2. And this is the first farmer who installed it, and he got an award from the minister, Fisheries Minister of Government of Kerala. And he has maintained a vegetable garden. And there are so many events which happened over the years, over 1 year, on the harvest of several farms like this, and these are all news clippings, and several people are involved. And now when we operate and started installing, we experienced a very difficult situation in certain place regarding digging for a pond. In some places it was rocky, in some places watery, and water table was so in the top, and constructing above is a bit difficult, expensive. So we now brought out another design which is under construction, and where everything is the same, but the thing is that the structure is above, and here also indigenization and cost reduction has been brought in, and the cost will be almost same as that what we do under the below ground level. And if you look into the units cost above ground level, the setup cost, that is the machinery and all, comes to 4,28,500. Pond construction comes 3 lakhs, and total project cost 7,28,500. But in the below ground level, it comes to setup cost 6,98,452. Pond construction 1,80,000 only. Total project cost 6,76,452. Now today, in the Prime Minister Matsya Sampada Yojana, the unit cost has been given as 7,50,000. So it can be brought within the budget provided by the government, and for which there will be subsidy. And this is how the subsidy goes. And 7.5 lakhs is the project cost, and general and OBC 40%, that is 3 lakhs. Women, SC, ST 60% as 4.5. And in the first year, we have been provided, or we have been entrusted with the responsibility to give away this subsidy amount, but now it is given to the state fisheries department, and for which every farmer who wants to acquire the technology should go to the respective district fisheries office and give a request telling that they want to avail 100 cubic meter RAS, and they should send an application to us in the format provided by NFDB, and for which we will be supplying the format whoever wants. And before I conclude, let us have a brief discussion about such different technologies available. Now, if you look into aquaculture as a whole, we will see the extensive, semi-intensive, intensive. And this comes under intensive system. And of which there are 3 technologies we can see. One is aquaponics, another one is biofloc. Now what I am speaking about is RAs. Among all these, RA is comparatively more expensive in terms of the structure. The one-time investment is slightly higher than the other 2. But the advantage is that it is applicable for a variety of fish species which dwell in water column and accept pelleted feed. And moreover, we have experienced that there is clear evidence and proof that significantly higher growth rate is there in RAS, especially in this backyard RAS design, what we are given. The design is very important. The 2 meter water depth is very important. The chemistry, the consistent chemistry is very important. The probiotics are very important. Then only we can expect the growth, in the case of gift, 350 gram within 120 days or 90 to 120 days. In some cases, it has gone up to 400 to 500 gram even within this period. Then another advantage, we have a total control over ammonia and nitrite by way of regulating water flow through the nitrifying bioreactor. And the system is equipped with the machinery to have 3 times circulation of water. That means 3 lakh liters can be passed on through the filter every day. But never we have an experience of increase in the flow rate than one time a day. Such a powerful facility is being built in the nitrifying bioreactor. And moreover, we can use the facility as brood bank, for seed production, as nursery, and as grow-out, which is highly versatile, which no other system will provide, and ideal for maintaining standard seed of carps as seed bank. This is a very important requirement because during monsoon we get enormous number of carp seed. What we'll do, we may not be able to use it at the same time. So we can have a stunting of the seed in this facility in different area and keep on giving the farmer as per the requirement the whole year round. This is a very important advantage which we have to look into. So compared to all other technologies, this RAS with this design, in our experience, with the data we generated, is highly versatile and flexible and affordable. And this work has been supported by so many institutions and individuals over the years, starting from Department of Biotechnology, Department of Science and Technology, Department of Fisheries, Government of India, National Fisheries Development Board, Cochin University of Science and Technology, Director of NCH, Dr. Valsamar Joseph, and the other faculty members as mentioned here, Dr. Jays, Sajivan, Shibin, and so many technical people. As we can read here, Sujit Kumar, Ambadi Kannan, and so many other people around here, they work in the field as technical personnel, and along with that, a company, a group farming corporation, helped us in manufacturing some of the components. And you will see there are so many people listed, and it comes to 35. So this is a concerted action. And on seeing the experience over 1 year, on accomplishing 85 installations, confidently we can say that this can be expanded throughout the country, provided there is same sort of support from all over. And the farmers also should realize the importance of it. Now there is subsidy available, and this has to be utilized. And whoever wants to acquire the technology can write to me and can can meet the concerned people and fisheries. This is a video on a very prospective farmer.
ഞാൻ പ്രധാനമായും കൺസ്ട്രക്ഷൻ ഫീൽഡിലാണ് ജോലി ചെയ്യുന്നത്. ഇതെന്റെ ഭാര്യ ലിസി, ബെത്ലഹേം ഞാറുലോ സ്കൂളിൽ അധ്യാപികയാണ്. ഞാനൊരു ഹോബിയായിട്ടാണ് മീൻ വളർത്തൽ തുടങ്ങിയത്. ഇപ്പോൾ ഇത് ഒരു സീരിയസ് മാറ്ററായി കൊണ്ടുപോകുന്നു. കുസാറ്റിന്റെ ഡിസൈൻ പ്രകാരവും ബ്രൈറ്റ് സിംഗ് സാറിന്റെ നിർദ്ദേശപ്രകാരവുമുള്ള ഒരു RAS പ്രോജക്റ്റാണ് ഇത്. ഫിഷറീസ് ഡിപ്പാർട്ട്മെന്റിന്റെ ലൈസൻസോടുകൂടിയാണ് ഇത് നടത്തുന്നത്. 3 ടാങ്കുകളിൽ 2 എണ്ണം ഗിഫ്റ്റ് സ്ലോപ്പിയും ഒരെണ്ണത്തിൽ കരിമീനുമാണ് നിക്ഷേപിച്ചിരിക്കുന്നത്. ഫെബ്രുവരി 15 നിക്ഷേപിച്ച ഗിഫ്റ്റ് സ്ലോപ്പി ഇപ്പോൾ ഏകദേശം 250-300 ഗ്രാം ആയി വരുന്നു. ജൂലൈ ആദ്യവാരം വിളവെടുക്കാമെന്ന് ആഗ്രഹിക്കുന്നു. റീറ്റെയിലായി കൊടുക്കാനാണ് തീരുമാനിച്ചിരിക്കുന്നത്. ഇതോടൊപ്പം തന്നെ ചെറിയൊരു പരീക്ഷണം എന്ന നിലയിൽ കുറച്ച് PVC പൈപ്പിൽ മണ്ണില്ലാതെ കൃഷി ചെയ്യുന്നുണ്ട്. തക്കാളി, ചീര, പച്ചമുളക്, വെണ്ട, ചേമ്പ്, ചീര, സെലറി എന്നിവയാണ് ചെയ്യുന്നത്. പുതിയ തലമുറയ്ക്ക് ഇതൊരു പ്രചോദനമാകുമല്ലോ. ആശ്ചര്യ വിശേഷവുമായി അടുത്ത വീഡിയോ.
Before I conclude, I would like to mention 2 important personalities of DBT. Because as I mentioned, it started in 1995 with a project. At that time, Dr. George John was the advisor of the task force in marine biotechnology aquaculture. Then it continued for all along this period for another 20 years. Dr. Ninave was the advisor, and these 2 people have contributed immensely to the development of all these. And they have enormous, several projects they provided one after the other, with which we can learn a lot and bring out this technology for the nation. And we are confident that this can go forward as a big movement and creating lots of food and employment and entrepreneurship. Thank you very much. For more details, you can note down this information, my email ID and my mobile number. This is WhatsApp number. You can send your message or a request for whatever you want. We will work together. Thank you very much.
Thank you very much, sir, for your detailed and very clear presentation. Sir, we have got a few questions. Shall I read out those questions, sir?
Definitely, please.
Sir, Mohammed Nadeem Khan has asked, what is the expected growth of Pangasius and tilapia in RAS?
In both the cases, tilapia gift will grow within 120 days, 350 to 400 gram. And Pangasius also to almost the same. And Pangasius can be grown for 6 months and harvest by around 750 gram. So in the case of Pangasius, we can have 2 crops. In the case of gift, 3 crops. And stocking density can be slightly modified accordingly, because everything is calculated based on biomass, not the number.
One Virupaksha has asked, is it possible to implement backyard array system in IMC culture?
Yes, one farmer here tried with the Jayanti Rogu and he got good growth. So
Okay,
it is
sir.
possible.
Okay, sir. So one Chavan Bell's course has asked, RAS looks very expensive, but biofloc with less investment, can we achieve the same results? Then why we have to go for RAS?
And installation cost is slightly higher than biofloc, but we have to work out the volume of water which is held in biofloc. Now here in this facility, we hold 1 lakh liter, and the person who asks question should work out for holding 1 lakh liter water, how much he has to spend. Here we spend 1.8 lakhs for the installation, and totally it comes to around 7 lakhs, 7.2 totally for 1 lakh with everything together. And for 1 lakh, he has to work out how much he has to spend, because what I see here, they are all maintaining 10,000 to 15,000 liters of tanks, and each tank costs around 50,000 rupees together with all the pumps, everything. So in that way, one has to work out. And second thing is the growth rate. The growth rate is very, very high in RAS. This is, I'm not telling, myself I'm not telling, it is spoken by the farmers who are owning both the systems. So they are opting for RAS. So when we work out economics, we have to look into all these aspects and then come out with the economics. Not only the amount what we spend at a particular time, one of the other durability. The biofloc tanks, how long it will remain, exist. That also very important. These should be put together and make an assessment.
Okay, sir. One Ms. Anmol Verma asked, does the slurry needed to be disposed of soon, or these can be transported to some distance far agricultural field?
Definitely it can be transported, no problem. No problem.
Okay, sir. Sinjini Chakrabarti has asked, is there an agreed amount of replication for fish behavior trial?
How many repetition? That particular word I didn't get.
Is there an agreed amount of replication for fish behavior in this RAS? I think
application means we have none. As I spoken, 85 units now. About 50 units are functioning, and we have got the data. And behavioral fish is very normal, and they accept food readily. And there is nothing, no abnormality we have seen. Everything is normal. So
okay,
sufficient observations have been made.
Okay, sir. One Ms. Abid Beras asked, bottom cleaning system is bottom cleaning system can be applied in RAS fish farming?
Now here the bottom cleaning is done by 2 ways. One is by swirling motion of water created by air injectors, and second thing is flushing device, which is kept at the bottom, which will flush down the sludge accumulated at the slopey side to the pit, and from there it is being sucked out. So no further additional cleaning device, just like siphoning, is required. Nothing is required. This is, if you operate properly, this is sufficient.
Okay, sir. Praveen Prasad has asked, Aquaponics with RAS, how salinity control and other minerals which acquire plant growth can be maintained?
No, that depends upon what plant you are using. If you are using saline water, you have to choose a plant which will live in that saline water. Normally, what we have seen is only fresh water. So, variety of vegetables people are cultivating, and aquaponics can be linked with this, not for treating water. Remember, not for treating water, but for utilizing the nutrients in water for plant growth. There also one thing what you have to remember: the plants which grow, which are grown along with this, will extract a lot of calcium and magnesium from water. And those situations, we have to be very vigilant to examine how fast this calcium magnesium falls down. If it goes calcium below 30 milligrams per liter and calcium magnesium 300 milligrams per liter, that will cause an instability in the physiology of the fish. We'll have to compensate it. So blindly, we cannot go for such facilities. We have to be very careful in analyzing the chemistry of water.
Okay, thank you, sir. Nitish Raj has asked, what are the major disease outbreak in this system?
Now, we have seen two diseases. One is columnaris, caused by Flavobacterium columnar, and second one caused by Streptococcus. And both the diseases could be easily managed by probiotic application. In a few cases, with the antibacterial substance which are permitted in aquaculture. Further, what we do is, we always are in touch with the farmers. So whenever a fish dies, they are advised to put in a polythene cover and keep in freezer. And they are being brought to the lab next day, and we use a kidney isolation. That means from aseptically, we take a kidney sample and streak on a plate. And from that, we understand whether the fish was infected. If infected, we will run an antibiogram with the permitted antibiotics. And we supplement the feed with the antagonistic bacteria, which will control this pathogen. In that way, we go ahead with the treatment of disease for the entire population. Even if one fish dies, that's an indication that pathogen might be there. So treat the entire fish stock. Within 5 days, we see that the disease gets subsided.
Thank you, sir. Same Nitish Raj has asked, can we go for polyculture in RAS?
We haven't experimented yet, but since we have got 3 cages, we can have 3 species together in one pond. That is possible.
Okay. Gurpreet Bhatia has asked, what is the land area required for setting up a unit, one unit?
One unit, the exact area is 45 square meter, but on the side we need again 2 meter width. So totally, if you have got 60 square meter is sufficient for one unit.
Okay, sir. I think all the questions, I didn't leave any questions. More than questions, we have a lot of compliments, and many have thanked you, sir, for a very clear and better presentation. I think we've come to the end. So I thank our speaker today, Professor Bright Singh, sir, for his very slow and steady but very detailed presentation, which had enlightened us with his insightful presentation. Sir, thank you very much, sir.
Thank you very much for the opportunity.
So as a formal gesture, I would like to deliver the vote of thanks. On behalf of the Guru Nanak Center for Research, I thank all the participants, and I wish to extend my grateful thanks to our Professor I.S. Bright Singh sir, who is a fellow of the National Academy of Agriculture Science and the KSC Emeritus Scientist, National Center for Aquatic Animal Health, Cochin University of Science and Technology, Kerala, for having accepted our invitation and sparing his valuable time and enormous knowledge and experience with his presentation titled Entrepreneurial Opportunities Through Backyard Recirculatory Aquaculture System in Fish Farming. Thank you very much, sir. I wish to sincerely thank our management, especially our most revered General Secretary and Correspondent, Sardar Manjit Singh Nair, our respected Principal, Dr. M.G. Raghunathan, for their constant support and guidance for planning and execution of this international workshop. I thank Dr. J. Jayanti, Dean Research, Guru Nanak Center for Research, for the opportunity given to me. I'm thankful to all the participants, Vice Principal, Deans, Heads, and faculty of different departments of Guru Nanak College for your participation. Last but not the least, I thank all the participants from across the globe who showed keen interest in their active participation in today's workshop, which made this a grand success. Once again, thanks one and all.
Thank you very much.
Thank you very much, sir. Dear participants, there is one more instruction. Tomorrow's program details, day 4 of this 8-day workshop, titled Use of Molecular Markers to Resolve Taxonomic Ambiguities of Species with Special Reference to Indian Mangrove Mudcrabs, by Dr. Anup Mandal, Project Manager, Central Aquaculture Genetics and Central Aquaculture Pathology Laboratory, Rajiv Gandhi Center for Aquaculture, the R&D Center of EMPEDA, Ministry of Commerce and Industry, Government of India, Chennai, tomorrow at 3 p.m. We shall all meet exactly at 3 p.m. tomorrow. Thank you very much.